Hello, my little mathematicians. Today, we are going to talk about the different parts of an algebraic expression and then combining like terms. So first of all, let's go through a little bit of vocab. An algebraic expression is an expression that contains a variable. Okay, and remember, a variable represents an unknown number. So it could be something like this, like the variable can be to the second power, okay, or there could just be one variable in the problem, or there could be two different variables, like two different letters, okay. Of course, there's so many more, but that's just an idea to get you that as long as it's an expression that contains a variable, it's called an algebraic expression, okay. This whole thing is an algebraic expression up there. A variable, I already said it earlier, it's a symbol, usually a letter, that represents an unknown number. So when we don't know something or the value can change, we use a variable or letter to represent that number. And we can choose any letter we want unless they specify, hey, please use a blank to represent this. So right here, okay, a variable is an unknown number that can change. So right here, this would be the variable and that would be the variable, okay? N is the variable. In that particular instance. Again, it doesn't always have to be an N or an X. You can choose whatever letter you want unless they specify a specific one for you to use. Okay, the next one is known as a constant. A constant is a number that doesn't change. And how you know that is it's a term with no variable attached to it. Okay, so there's nothing that could ever be multiplied by it to get it to change. It's just by itself. So right here, this would be the constant up above. Okay. So again, the constant right here would be the 10 because it doesn't have a variable attached to it. It's always going to stay a 10 in that problem, no matter what you substitute in for the n, because it's not getting multiplied by n, so it's not affected. Okay, the next thing, vocab word that we want to focus on is a term. A term is what makes up the algebraic expression. It's made up of individual terms. So this guy, and this guy are all terms. So this one right here is a term, this one's a term, and this one's a term. Okay, it's the parts of an algebraic expression that are added or subtracted. So when you see a plus or minus sign between them, that separates one term from another. So this would be a term, this would be a term, and this would be a term. So 3n squared, 5n, and 10 are all the terms for that particular algebraic expression. Okay, and then the next thing they expect you to know is what's called a coefficient. Say that with me, coefficient. Okay, a coefficient is a number that is multiplied by the variable in an algebraic expression. So it's the number in front of your variable. Okay, it's this 3 and it's this 5. So 3 and 5 are the coefficients in that particular algebraic expression there. See if you can identify the coefficients up here. What do you think they are? Yeah, if you said it's this 2 and this 9, you would be right. Those two things are the coefficients. And then finally, a like term. Okay, so we already established what a term is. It's the parts of an algebraic expression. But a like term, they have to have the same variable or same letter raised to the same power. So example, 3x and 5x. They're both x's and the x is to the power of 1. There's nothing written there. Okay, or we could say 2x squared and 4x squared because they're both x squareds. They're both x's and they're both raised to the power of 2. An example of a not like term would be 3x and 3y. Well, this is an x and this is a y. They're not the same letter. Okay, or even if they're the same letter, like 2x and 3x squared, they still aren't like terms because this is raised to the power of 1 and this one's raised to the power of 2. So it has to be both the same letter and raised to the same power in order to be like terms. So underline that these are not like terms so you don't think that those are like terms later. All right, let's go ahead and take a look. Have you try to break apart these two algebraic expressions into their different parts based upon the vocab that you just learned. So let's say all the different terms that make up this expression. You have a 5y squared. And I know up here, because I was circling stuff, it's important to bring the sign with it because if it's by itself, like that's a -2, that's a -3y. So bring the sign with it. And if it's a positive, you don't need to write the sign. It's implied that it's positive. So it's basically just if it's a negative. All right, so you have 5y squared as one term, then a y, then a -2, then a -3y, a 4, and a -7y squared. Those are all the terms for this individual problem. See if you can identify all the terms here in this one. Okay, so pause it, come back and unpause. Did you write n squared, -3n? Remember, if it's negative, bring the sign with it. And then -2, then -5n, and then 10. Because remember, terms are separated by plus or minus signs. Okay, now coefficients are the numbers that are in front of all your variables. So this one, what's in front of it? A 5. What's in front of this one? When there's nothing there, it's technically a 1. Don't say 0 because 0 times y would be 0 and the y would go away, right? So it's a 1 when there's no number present. This is a constant, so it actually is not a coefficient. A coefficient is the number in front of a variable. So since there's no variable, this has no coefficient. This one is -3. That's another constant. This coefficient is -7. Okay, see if you can write the coefficients for these guys. Okay, hopefully you wrote a 1, then a -3. That's a constant, so skip it. A -5, and again, that's another constant, so skip it. Now, out of all those terms, which ones are like terms? Do you see any other y to the power of 2? Yep, right there. So 5y squared and -7y squared are like terms. Do you see any others? Like, do you see a y to the power of 1? Right here. Because remember, there's no exponent written. It's like a little imaginary 1 right there. So y and -3y are like terms. Okay, and then you have constants. Constants are also like terms. You would combine those as well. Okay, those are all of the like terms for that algebraic expression. See if you can find the like terms for this one over here. Okay, so n squared. Do you see any other n squareds? Nope. Do you see any other n's to the power of 1? Yes, there's the -3n and the -5n. And then do you see any constants? A -2 and a 10. So those are all of the like terms for that algebraic expression. Okay, if you got that right, great. You're kind of getting the vocab down that now we can start some of the problems we have to actually solve. Okay, so go ahead and turn the page. And let's take a look up at the top. Okay, to simplify an expression, first do the distributive property or other multiplication if needed. So sometimes it's not always necessary, but if it needs to be done, do that before you start combining your like terms, okay? After you do that, then combine or put together, so to speak, your like terms. And now you guys are expert at identifying like terms, right? Okay, there's nothing to distribute here. Like this is an example of needing to distribute. You need to distribute that 3 to both the things inside the parentheses. But here, there isn't any. So let's just say this and this are my like terms, right? And circle the sign in front of it so that then it's easier to determine if it's a positive or negative. So this is an imaginary 1, an imaginary 1. 1 plus 1 is 2x. Okay, so when you're combining your like terms, you circle your like terms, okay, and do a different shape around different like terms so that then you can see what goes together. And then when you put them together, you keep the variable exactly as it was and you combine the coefficients. Now notice how I didn't use the word add because some of them will be positive and some of them will be negative, so you combine them. If it's 7 minus 4, well then do 7 minus 4. If it's 7 plus 5, then do 7 plus 5. So let's take a look at this guy. This guy says 5y and 2y. They both are y's to the same power. So let's circle both of these. These are both like terms. So keep the y the same and then combine the numbers in front. What's that name for a number in front of a variable? Coefficient. Combine the coefficients. 5 plus 2 makes 7, so that combines into 7y. Okay, now we're going to get a little bit trickier. Do you see any other x's? Yes. This one and this one. Do I circle this one? No, because it is not a like term. I'm only going to combine these two, so keep it an x, and 11 plus 4 is 15. And then you just tack on that other term that has no friends, plus 3y. Okay. The next one we want to do is sometimes we need to distribute, right? So I'm going to distribute this 3 to both things inside of the parentheses. So you have 3 times that n, bring down your plus sign, and 3 times that 7. And then you just tack on the plus 4n at the end. So 3 times n is just 3n, but 3 times 7 is 21. So now you're to here. Do you see any like terms? Yeah, I see this 3n and 4n. So those combine. 3 plus 4 is 7n, and then tack on your constant of plus 21. Okay, this one, the 3a, nothing's happening, so just bring it down. Plus, I need to distribute that 2 to both things inside the parentheses. So you have a 2 times a, bring down your sign, minus, and then you're distributing the 2 to the 3b. Okay, so you have 3a, and then 2 times a is 2a, minus 2 times 3 is 6b. Now, do you see any like terms? I see an a and another a. So 3 plus 2 is 5a, and then tack on that minus 6b, because that's not a like term. It has a different letter. Why don't you go ahead and try example 8? Okay, so you paused it. Now you're back with us. You unpaused it. Okay, bring down that x, bring down that x, distribute that 3 to that first x, bring down your sign in between, and 3 times 5. So that simplifies to 3x plus 3 times 5 is 15. And bring down your other things in front. So do you see any like terms? I see an x, and another x, and then a constant. So 3 plus 1 is 4, plus another 1 is 5. And if it helps, you can write a little 1 in front of there. But if you have an x and another x, you have 2 x's, right? And 2x plus 3x is 5x. Now just tack on that constant at the end. And there you go. Okay, this one, go ahead and try it yourself too. And why don't you guys try this one? We haven't done one like this yet, but try it first before we go over it together. Okay, so here we go. We have a 2m, a 5m, and a 10m. They're all m's, so just combine them all. 2 plus 5 is 7. 7 plus 10 is 17m. Now this one looks the same as ones we've done. So you're like, what do you mean we haven't done one like this yet? We have a C, another C, and another C back here at the end. Well, 1 plus 6 is 7, right? And 7 minus 2 is 5. I know that doesn't seem like a big deal, but some people don't circle the sign with it. And so they just add 1 plus 6 is 7, 7 plus 2 is 9. Oh, I have 9 C's. Circle the sign with it. This is a minus 2. So you're subtracting 2 C's from these 7 C's. And then, of course, you just tack on your constant at the end. If you got that right, good. Okay, E plus plus another E. How many E's do you see? 1, 2, 3, 4 E's. Done. Okay, here's another tough one. I first need to distribute. So you have 2 times y plus 2 times 7, and then bring down that minus 5. 2 times y is 2y, plus 2 times 7 is 14. And now combine your like terms. There are no other y's, but remember, constants are like terms. So I'm going to combine those two constants of 14 minus 5 is 9. And don't forget to bring that 2y down in front. I probably would have done that first. Okay. Distribute. So bring down that k, because the 6 is only being distributed to the numbers in front of the numbers inside of the parentheses that it's in front of. So 6 times k, bring down that sign in between, and 6 times 10. So k plus 6k minus 6 times 10 is 60. Do you see any like terms? I see this k and this k. So 1 plus 6 is 7k. And then bring down that minus 60. Okay. Try this one on your own. Bring down the 9w plus 3 times 7. Bring down that minus sign, 3 times w. Okay, and then 9w plus 3 times 7 is 21. Bring down that minus sign, and 3 times w is just 3w. Do you see any like terms? That 9w and that negative 3w. So 9 minus 3 is 6 w's. Tack on your constant of plus 21 at the end. Okay, the next one says, determine if all the expressions are equivalent. Explain your answers. So first of all, let's just go through and try to simplify all of these in this row, and then try to simplify all of them in this row. And then we'll see if they're all equivalent or not. Okay, so make them as simplified as possible. And by the way, that's what you were doing up above in examples 1 through 14. You were simplifying the expression. Okay, remember, you can always pause and then unpause to come back. This one, there's nothing else that you can simplify, so it's fully simplified. Okay, 9y minus 4y. Well, 9 minus 4 is 5y. Bring down that plus 10. Okay, that is fully simplified now. Distribute. You have 5 times y. Bring down your plus sign, and 5 times that 2. So 5 times y is 5y, plus 5 times 2 is 10. Fully simplified, because you can't combine a constant with that one with a variable. All right, I see y's. So there, and there. And then I also see constants. So let's do a different shape around my constants. So 1 plus 8 is 9, and 9 minus 4 is 5y. And then the two triangles, the two constants, 6 plus 4 is 10. And that's fully simplified. So are they all the same expression? Yeah, 5y plus 10. Bonus for you. What if one of them said 10 plus 5y? Is that equivalent? Yeah, because think about it. If you were to have like 2 plus 3, isn't that the same thing as 3 plus 2? They both equal 5. So the commutative property lets me switch them in order. And this would be the same thing as this. We just prefer to always have the variable one written first. Okay, so are all of these saying the same thing? Yes, they are all equivalent. They are all equivalent. Equivalent just means equal, right? It's a fancy word for equal. Because they all simplify to 5y plus 10. They all simplify to the same thing. So that makes them equal or equivalent to each other. Okay, and then finally, my next one. When you go ahead and you simplify this, distribute the 4 to the x and distribute the 4 to the 3. So 4 times x, bring down your sign in between, and then 4 times 3. 4 times x is 4x, plus 4 times 3 is 12. You can't combine it because this has a variable and the other one's a constant, so I'm done with that one. That has a variable, that has a variable, so 3 plus 1 is 4x, and then I want to tack on my constant at the end, plus 12. And it's a positive 12 because there's no negative sign in front of it. Okay, distribute. You have 4 times x, bring down that minus sign, 4 times 2. So you have 4 times x minus 4 times 2 is 8. There you go. And I know some of you are like, wait, nope, I can just stop and say, no, they're not all equivalent. But what if this one's equivalent to this one? If it says, are they all equivalent? You're right, it would be no. But if they said match equivalent expressions, these two would be equivalent. And who knows, maybe these two might match, or maybe this, and this one are the same. Or maybe it's just these two that are the same. Okay, so you don't know what it's specifically asking sometimes. So let's just go through and simplify all of them. Plus, this one's a good one to practice because this one's tricky. So see what this one simplifies to. Even though we know, no, they're not all equivalent, still try to simplify this one. Okay, that 5 only gets distributed to the things inside the parentheses, and then bring down your other items. And then 5 times x is just 5x. 5 times 2 is 10. Bring down your minus x and your plus 2. Okay, what like terms do we see? Well, I see this x and this x, and then those two constants. So 5 minus 1 is 4x, and 10 plus 2 is 12. So the question asked, are all the expressions equivalent? No. Only 3 of the expressions are equivalent to each other. The first, second, and fourth one. Okay, the third one is not. If you got all of those right, awesome. There was a lot involved in here. You needed to know like all the different vocab and how to distribute and how to combine like terms. Congratulations, you just mastered a lot of different concepts, my little mathematicians.